All right, well, thank you to the presenters, Ron, Liz, and Ryan, for letting me tag along to their show here, and to the organizers of the webinar to talk a little bit about how we are trying to apply some of these techniques to the urban forestry context. So I'd like to point out, first and foremost, the Philly Tree Plan, which is our recently released 10-year strategic plan for the planting and care of the urban forest, guided by values of environmental justice, community engagement, and sustainability. This was a massive undertaking for those involved in production of the plan, and we'll set the stage for how we employ some of these techniques. So I'm going to move fairly quickly through 3 potential applications in urban forestry for some of these phytotechnologies that we're in the early phases of implementing, and then go a little bit more in depth into their application in the natural lands, which is where the focus of my work is. So one of the main findings of our urban canopy assessment was the unequal distribution of canopy across the city, which has obvious impacts in public health and can lead to temperature extreme differences. And we measured a 22-degree Fahrenheit difference from some of the hottest to the coolest neighborhoods within the city of Philadelphia. So we are interested in simple, cost-effective, and fast opportunities to establish canopy cover in high-use public green spaces. And so we established some hybrid poplars provided by Ron and his team in Hunting Park Playground in North Philadelphia, one of the priority neighborhoods. And we'll be monitoring their ability to cool this essential and high-use space for the neighborhood. Philadelphia also has a pretty extensive green stormwater infrastructure program. The Philadelphia Water Department kicked off the Green City Clean Waters program in 2011, and since that time have implemented hundreds of GSI projects across the city, with a goal of over 9,000 green acres across the city by 2036. And so this represents a pretty significant need for high-performing plant species to thrive in conditions that can experience pretty significant moisture extremes, both inundation from engineered stormwater capture, but since they're designed for rapid infiltration, it leaves them with little moisture holding capacity in between rainfall events, which more and more we're experiencing irregularity in those patterns. And so using the phytorecurrent process that the phyto team outlined can be a useful technique. Since these are engineered soils, we can identify clones best suited to thrive in these environments and increase their performance. The third I wanted to mention was vacant lands within the city of Philadelphia. These are obviously a pretty extreme environment to try and get trees to grow. And we're fortunate to have a nonprofit partner, the Pennsylvania Horticultural Society, who manages a land care program that uses gardening and landscaping to clean, green, and maintain vacant lots. I believe it's over 13,000 vacant lots across the city. And so they do extensive work to clean and prepare these sites for planting and fencing, but the sites can be legacy disturbance, soil impacts can be significant. And so the ability to provide plant material that can thrive in these kind of challenging conditions is going to be really important. I'm going to shift now to our forested natural areas, which is the focus of my work and where we have 2 studies that we've implemented in the past few years using some of the phytotechnology approaches that Ron, Liz, and Ryan mentioned. And to give you an idea of the scope, we have about 6,000 acres of natural areas in the city, represents 60% of public parkland. They are 75% treed, and they represent almost 30% of the city's total canopy cover. So a pretty significant component of the urban forest. And while it might not always look like quite as harsh as some of the other sites that we've looked at, conditions can be very difficult for establishment. The picture on the left is what we would typically want to see in these spaces: native, mature, dominated trees with native species recruited into the understory and the midstory, poised to take over as mature trees come down. But unfortunately, what you see on the right is more typical of conditions across our network. There are remnant mature native trees in the overstory, frequent disturbance, and an understory that's typically dominated by invasive shrubs and vines that really suppress any native seedlings that have made it past all of the white-tailed deer and preventing succession from proceeding. So The picture on the left is what our sort of standard practice looks like. We will control invasive species and process the site to facilitate planting. Because we have so many invasive species and an overabundance of deer, we don't really have much in the way of native seedling establishment, or I'm sorry, natural regeneration on site. And so we're reliant on artificial regeneration. And so we manage a small container nursery for the city to address that need. And the standard practice is a wide variety of native species. They're seed grown. And so it involves identifying source locations, gaining permits, doing seed collection, processing, pre-germination treatment, seedling culture, and growing plants to a size that we can use on these sites, which typically represents between a 3 and a 5-year process from start to finish. And we're producing, 50 to 75 species per year with a very small staff in a simple facility. So it's a very complicated and intensive labor and financially intensive process. And while we're successful a lot of the time, we're always looking for opportunities to simplify the process and find sort of the path of least resistance to desired future conditions. So I want to call out Max Piana and Rich Hallett from the Forest Service, who have been our frequent collaborators and connected us with Ron, Liz, and Ryan and their work, and are helping us answer some questions about how we can use these phytotechnology strategies, translate them to our urban practice, and accomplish some of our objectives. And so the main questions that we're asking of some of these plants and techniques are, can we accelerate canopy establishment, facilitate native tree plantings, and most importantly, reduce post-planting maintenance requirements, which are extremely intense in our environment. So first of all, these plants provide sustainable and time and cost-efficient local plant stock. Ron, Liz, and Ryan talked about their process, and so they provided us with some starter stool bed material, and using their guidance, we early on in May of 2020, in early pandemic times, we did manage to establish a stool bed on site at our nursery, which is about 1/10 of an acre and has 144 separate blocks of hybrid poplar and also locally collected poplar and willow genotypes with 16 stools of each plant. We irrigated for the first season for establishment, and since then they've seen limited maintenance, and we've been able to harvest thousands of 10 to 20 foot cuttings from each of these blocks every year since that time. So they're simple to grow and harvest and process. The cuttings can be stored in a refrigerator for a long period of time before use, either as direct installation like they showed, or in our situation, most of what we use are containerized stock. And so they provide us with a lot of flexibility and eliminate the need to travel to source seed for our standard pallet. So we're now working to figure out what are the stock types we can produce with this plant material, as our site conditions can be fairly varied, and we try to match the stock to the site requirements and the ultimate goals. So here you can see some roughly 12-inch cuttings, rooted cuttings in a 10 cubic inch plug, which were grown in about 7 weeks in a greenhouse setting. And on the right, we went from a cutting to a 7-foot tall, 3-gallon pot in a single growing season with pretty minimal care in the nursery. So again, a lot of flexibility in what we can produce from these plants, which will be very helpful as we tailor it to different site conditions. So the 2 studies that we've implemented, I'm going to get into just briefly here, and are very different site types and with 2 slightly different goals. The first is to create new forest where tree cover was entirely lacking, and the second is to restore and sustain existing forests within a larger, mature forested site. So the first study is what we refer to as the Parkwood Afforestation Study. This was a legacy dumping site on public land. It was a recreation center that was adjacent one of our stream corridors, and there was a decades worth of dumping of construction and road debris on the site. You can see in the aerial the impact that it had on the landscape, and on the left some of the conditions that we are asking plants to grow in here. And so we're really looking for selection of trees that can tolerate these kind of conditions, which is a very limited number, and then fast growing species so that we can accelerate canopy closure and get the benefits associated with that. So this was a pretty harsh condition as far as the natural areas are concerned. It's somewhat atypical in what we see, but obviously what we learned here will likely have more to do with some of the other urban sites that we saw as far as this condition of the soils and the incidence of contaminants. So I want to call out PowerCore PHL, which is a workforce development program that we work very closely with and are fortunate to have as a partner. They engage on and underemployed 18 to 30-year-olds in a paid 24-month experience, train them on all sorts of green job skills, and they were critical on the installation, maintenance, and monitoring of the site. They planted over 6,000 trees in spring of 2022. So this project is in the early phases. We unfortunately had a pretty severe drought in the summer of 2022. If any of you are in our region, you're familiar with that. So we did see high initial mortality on the site, but we did see a lot of survival, and we're hoping to see what we can learn about the variety type tolerance to drought conditions from this project. So seeing what survives and thrives in the long term might tell us which varieties are more appropriate for droughty conditions, which we're encountering more and more. The second study is in the northeast of the city as well, and is focused on managing canopy gaps within an otherwise mature forest stand across Philadelphia's natural areas. We have a largely even-aged, mature, native-dominated canopy. And so what we're seeing more and more are single and multi-tree canopy gaps formed because of the age of the trees, incidence of pests and disease, the increasing pressure of climate change and extreme weather events. And so we're really hoping to focus on some of these spaces so that we can protect the surrounding healthy stand by addressing gap conditions before they degrade too far, like some of the first picture that you saw. So we're currently working to adapt some of the urban tree canopy mapping techniques using LiDAR. So we've used those to show canopy change over time. We're working to adapt that process on a shorter time scale so that we can identify canopy gaps shortly after they're formed and react quickly using some of the fast and easy to grow poplar and willow to capture a site before it degrades, and then basically buy us some time before we can implement a longer term management plan. So this site, as you can see, there were 16 gaps split into 32 separate plots where we're testing the use of these fast-growing hybrid poplar and willow along with some of our more standard oak and hickory species to see how they suppress invasive species on the site, facilitate establishment of the natives, and critically, if they can reduce any of the post-planting maintenance requirements for getting trees into free-to-grow conditions. So this was planted in fall of 2022. So again, early on with no concrete findings to share at this time. But we planted almost 1,000 of our sort of standard pallet trees, white oak, red oak, mockernut hickory, and some disease-resistant American chestnut. And then in half of the plots, we installed at a tight spacing between those trees, almost 2,000 of the fast-growing willow and poplar that we grew from our stool bed to see if they can help capture the site, suppress invasives in the early disturbance timeline, and allow for establishment of the oaks and hickories. And then we will measure and monitor, as Ryan alluded to, the need for monitoring post-planting is so critical in these situations so that we can learn and adapt our practices. And so we'll be engaging in yearly monitoring of these sites, see how the nurseries perform, and then at a certain point, hopefully we will have to go in and thin those out to allow for release of the oaks and hickories. And so with that, I will turn it back and hopefully have some time for questions, and thank you for the opportunity.